This is an example on the application of ordinary differential equation applied on depreciation of value. In this example, assume that the rate of depreciation of a machine is proportional to its instantaneous value. So what this statement means, say V is a value on a machine at any time at time t. We know that as time goes on, the value of the machine will depreciate. In the beginning, it may be very expensive. After 5 years or 6 years, it goes down. And the rate of depreciation means this value will change with time, is proportional to its instantaneous value. That means this is equal to some number times a value where we expect alpha negative. This is because the value v is decreasing. We will solve this differential equation dv dt equal to alpha v. We will solve this by separation of variable. So dv over v equal to alpha dt. So the left hand side only involving v, right hand side only involve t. Integrate both sides. Then the left hand side will be ln v after integration, and right hand side will be alpha times t plus a constant. Remember, you only add the constant to one side. And alpha is a constant, therefore integrate alpha just alpha t plus a constant. And then you recall that if we have ln y equal to x, it means where y equal to e power x. So that means v is equal to e power alpha t plus c. But this can be rewritten as v equal to e power alpha t times e power c, where c is a constant. Let's call this v naught. So this is v naught times e power alpha t, where v naught is e power c here. Now, what is the value of v naught and alpha? Let's go back to the question. It says that initially the machine costs 30,000 when it is brand new. This actually tells us when time t equals 0, the value of the machine is 30,000. So put this information into the expression we have t equals 0, v equals 30,000. Then we get 30,000 equal to v naught times e power 0. But then e power 0 is 1. So that means that v naught is equal to 30,000. Therefore, we know the value of the machine is given by v equal to 30,000 e power alpha t. So we know v equal to 30,000 times e power alpha t. Again, what is alpha? you have to go back to the question. It says that the value of the machine worth 20,000 after 2 years, which means that when you put t equal to 2, the value of the machine is 20,000. So after the substitution, we put t equal to 2, v equal to 20,000. We'll get 20,000 equal to 30,000 times e power 2 alpha. So after cancellation, I have 2 over 3 is equal to e power 2 alpha. So what is alpha now? Taking ln both sides, get ln 2 over 3 is equal to 2 alpha, or alpha equal to half times ln of 2/3. Then you press the calculator. We find that alpha is approximately negative 0.203. Notice that alpha is negative here. So we know V naught is 30,000, alpha equal to half ln 2/3. That means that we have the complete expression for V. We can do calculation now. What we're going to do is calculate the value of the machine 5 years later. Since we know V equal to 30,000 times e power half ln 2/3 t. So we put t equal to 5. We get V equal to 30,000 times e power half ln 2/3 times 5. Press the calculator. You get the value approximately 10886.62. Continue the next calculation. We want to know when will the machine be worth 5,000. So we take V equal to 5,000 and try to figure out what is t. So put this in. I get 5,000 equal to 30,000 times e power half ln 2/3 t. Divide both sides by 30,000. I want to figure out what is t now. I get 5,000 over 30,000 equal to e power half ln 2/3 t. 5,000 over 30,000 is 1 over 6. So we have 1 over 6 equal to e power half ln 2/3 t. Continue the calculation. In order to find t, I will take ln. Ln of 1 over 6 equal to ln of e half ln 2/3 t, which is equal to half ln 2/3 t. This is because you can actually bring down the power, and you know that ln a power n is equal to ln equal to n ln a, and ln e is equal to 1. And now I want to find t. So t equal to ln 1 over 6 divided by half of ln 2/3. So call on my calculator now. I have a fraction of ln of 1 over 6 divided by half with 0.5 times ln of 2 over 3, and that is equal to 8.838 or 8.84 years. That finish this example. That means that the machine will worth only 5,000 when it's waited 8.84 years.